Okay, right now I'm learning how to add hydrogen halides and water to alkenes. And it's a fairly simple process. The only thing you have to take into consideration is, like, for these two examples, I'm just using water, is that you have to add the positive side of water, which is H+, and the negative side, obviously being OH-. So you add the positive side of hydrogen to the carbon in the double bond that has the most hydrogens bound to it. There's the rule right there. Major product will have positive part of water, H+, bonded to carbon on double bond that has the most hydrogens bound to it. So if both carbons on the double bond have the same amount of hydrogens, there will be only one product. So in this equation here, we have 2-methylpropene plus water. And your major product will be 2-methyl-2-propanol, and your minor product will be 2-methyl-1-propanol. So this carbon here, that carbon there on the double bond, the latter carbon, will take on the positive side of the water because it has more hydrogens bound to it. See, it has two hydrogens bound to it. And this one here has no hydrogens bound to it. And that's why there's the product there, see? CH3, 2-methyl-2-propanol. The latter carbon, the one at the end, takes on the hydrogen, and the carbon that was on the other side of the double bond takes on the OH. So say, for example, both carbons that are comprising that double bond have the same amount of hydrogens bound to them. There will only be one product. There will not be two products, a major and a minor product like this. And this here is propene plus water. You have your major product, which is 2-propanol, and your minor product, which is 1-propanol. So the latter carbon on the double bond has 2 hydrogens, while the other carbon only has 1 hydrogen bound to it. So that carbon will take on the positive part of the water molecule. And as you can see, I drew out the major product, but I made a mistake in that. Well, I'll talk about that later. You can see the product right there. CH3, CH, CH3, the OH, the minor product, the negative part of the water bound to the carbon that had only 1 hydrogen bound to it, and the positive part of that water, which is the H+, bound to the CH2. And here's your minor product. The minor product has the negative part of the water bound to the carbon with the most hydrogens bound to it. And the positive part of the water is bound to the carbon with the least amount of hydrogen bonds to it. So it's just the reverse of the major product. Okay, the mistake I made here was I put the OH in the major product, I put it in the middle. You see I drew an X to it? I put it in the middle. When the OH lands in the middle, like in this instance, you're supposed to branch it off. Like I said here, if OH lands in the middle of equation, use a visible bond. And there it is, right there, CH3. See, there's that visible bond bonding the OH, H, CH3. And the mistake I made here was I called it 3-propanol when it should be called 1-propanol. You're supposed to give the constituent the smallest number possible. So the constituent here would be OH. You want to give that all. That makes it propanol, the smallest number. So if 3, you can call it 1. Instead of counting 1, 2, like 1, 2, 3, you can just count it 1. Just count it reverse. Okay, so that is, so you're wondering, okay, I did addition of hydrogen, halides, and water to alkenes. I only added water in these two examples. In the next examples, we'll do ones with hydrogen. You'll see what it's like when the carbons that are involved in the double bonds have the same amount of hydrogens bound to them, meaning you only get one product. Okay.